Yeah, you do the whole thing. Do the whole thing.
Why can't like I do A and then someone else do B and then
Well,
someone else do
it
C?
depends how A goes, whether or not I'll go with that.
Well, we have this first circle,
Thank you, sir.
and it says it's non-conducting, which
It's
means
non-conductive, which means
the
what?
charge is uniform throughout.
And it says, yes, it's spherically symmetric. It may not be uniform. It may be much larger outside and less inside, but it's spherically symmetric. It means it's symmetric in all directions. Reading from the center. Yes.
Then we have another circle. That one's supposed to be dotted though.
That was supposed to be dotted, and it's not a real thing, right? There's one point P on
this is
there.
point
All right.
P.
So they want to find the electric field at a point P, distance R is greater than
That's point C.
A, and A should be the radius of the circle, right?
This is R.
So to the right of the center sphere. So what if I like the field there? Go ahead.
So the direction would just be directly out.
Directly out, yes, sir. If it's positive, is it positive? How did you know that from the information?
Q is greater than 0.
Q is greater than 0, so positive, so therefore like to go radiating out. Correct.
And then we do Q enclose over E naught equals yay.
Okay, so on the AP test, you're going to write that properly one time, right?
So okay.
Because I will take it on your test, right?
Integral enclose.
Okay. And then next line, you write A.
Okay. And then the magnitude would just be Q enclose over E naught A.
And what's the area? Area of the shape you drew?
It's 2 pi r squared. Or 4 pi r. 4 pi r squared.
Square. You need to drop the enclosed and use their Q. Okay. I think it's R from the center, isn't it? So move back to the direction which is just
Yeah.
R to the right of the sphere center. So
Yeah, it's from point C, which is like the center. Equals E.
Okay, you need to use their R, which is a capital. Alright, so do that. Okay, don't lose points for that. Okay. That's the right answer, right?
Can you
Yes.
write it like that and then rewrite the R? Like
Yes, absolutely. They'd expect that. They'd expect you to use an R and then put R, capital R. But you can't not have the R's, the capital R. That's not allowed.
for your answer.
Right. They say, well, they don't know which R we're talking about. It's that's one of those ones where they sometimes they'll give it to you because they're so I'll give that to them. Sometimes they don't because they're like, well, you really should have used an R. Okay, so that's good. So now next B, determine the flux of an electric field through a spherical surface centered at C and passing through point P.
So the flux
Flux. What's the flux?
equals EA.
Okay,
And then that's our E.
that's your E.
And then the A is going to cancel out. So it's just the flux is Q over E naught.
For those of you who like to save time, you can use the left side of the equation, not the right, right?
Yeah.
But you know, if you do EA, you're going to get the right answer too. If you have to.
Wait, is it the I? Isn't it just the circle?
That's what I thought.
You can drop the top and bottom. It's done uniformly by lots of people. Technically, those eyes, those things have one of them. I've seen it by lots of people do it the other way. In fact, I'm not sure. The formula should have to be dropped it on. Take a look at it. Yeah, there you go. All right, you got one more problem to do, and this is where the problem gets really weird. One problem to do, we haven't run into that before, although the next problem should be easy at this point. So harder problem is C. C is a little weird.
The inner circle. So we have the point P circle.
Right.
We still have the distance R. And then now there's a point down here that has a charge of negative Q. And this has a charge of positive Q.
Right.
So it's going to be pushing it at this point. It's going to be pushing it out, and then this is going to be pulling it down. So this is going to be a 45-degree angle.
Perfect.
Down of right. And then,
Right, good choice.
oh yeah, I didn't know how to calculate the magnitude.
That's the
Or it's
part that
just,
should be the hard part. Now, you drew this already as if you know exactly how to calculate the magnitude. That's the part that's interesting.
oh, I think it just,
That should have been the struggle.
Yeah.
That should be the struggle right there. So the first part would be how much is the electric field for that first component you drew?
Q over E naught over
So
Q, Q over
let's label that first one you drew. Well, A is what?
4 pi r squared.
Let's do 4 pi r squared.
I'm just going to draw it out here.
That's a capital, right? Yeah. Okay, so you just have to figure out the component in the downwards direction, right?
Yeah.
What is the component in the downwards direction?
Q over E naught. Is it? I don't know.
It's an electric field as well, right? So you'd have to
Yeah.
use the same exact equation, right? For the bottom.
Yeah, but it doesn't have an area.
That's okay. You're the one that chooses the area, right? You're the one that draws the sphere.
Oh.
Right? Okay. So what would that look like if you did it that way?
That would just be Q over E naught at 4 pi R2 squared. Right? Because this would
say
be
the R's
different.
are the same.
Oh, okay. So it would be the same thing.
And the Q's are the same, right, too?
Yeah.
So what's the magnitude of that second piece?
The same thing.
Same thing. And so how would you figure out what the net magnitude is?
You do Pythagoras.
You Pythagoras. Let's see it. The second one, well, see, the problem is the negative chooses the direction, right?
Yeah.
So it's just going to be a squared plus b squared plus c squared. The negative is what's losing it. The affected by the fact that it's going to be 4 by 3 down your page. It's interesting, they didn't give you much notation here. I'm wondering how they graded that someone. I want to look up the 1997 square root, right?
Yeah.
Since those are the same, you're going to end up with 2 of those, right?
Yeah.
So you end up with the square root of 2 in front of that whole thing.
Right here?
Yeah, no, just go ahead and take the next one. Next up would be square root of 2 times out of the expression, right? Right. Well, because you got 2 of them.
Oh.
They're the same, right? So it'd be the square root of 2 times, well, keep your square bar going. And then you've got parentheses. Those are the same, right? So you're just adding them up. So 1 plus 1 is 2. Okay. So you still need a Q. Squared. And parentheses squared, right? And then how would you simplify that? Now we go away, you just got to square root of 2 out front. So square root of 2 times the expression, and you're done. And again, you have to indicate the direction because they asked for it. I'm not sure how they graded that part, frankly, because they didn't give you, didn't say right and left, did they? Well, they did say right. So they said right is sphere center. And then they say the other one located below. So that would be 45 degrees
Down of right.
below. They use the word below, so I use the word below. I assume they accept down. I can't imagine they would say, oh, well, that's not right. So that would be good.
Okay.
Beautifully done, sir.